So in section 2.2, we're actually going to start solving inequalities. You're going to see a lot of similarities to what we're going to do today to what we did in chapter 1 when we were solving equations. Solving an inequality is very similar to solving an equation. One of the biggest similarities is that we use these properties of equality like we did to solve equations, which basically says whatever you do, whether it's add, subtract, multiply, or divide, you have to do the same thing to both sides of the inequality. So let's write that down. You must do the same thing, so perform the same operation to both sides of the inequality. So that's how we're going to go ahead and solve these inequalities. So let's take a look at the first example. It says, solve the inequality, graph the solution. We have example 1a here. It says x minus 6 is greater than or equal to negative 10. So to solve this, I need to get the x by itself. I'll do that by using inverse operations. Because it says minus 6, I'll write plus 6. And then if I'm going to add 6 to that side, I also have to add 6 to the other side, which means I'm left with x. My inequality doesn't change. It's still greater than or equal to. And then I'll actually add the negative 10 and 6, and I'll get negative 4. So my inequality says x is greater than or equal to negative 4. That's my inequality. And now I need to graph that, just like I did in section 2.1. I'll do that by putting negative 4 in the middle of my number line, and then counting up from negative 4, so getting less negative, and down from negative 4 on the other side. After I have my number line labeled, I'll go ahead and put my circle at negative 4. Because it's greater than or equal to, it has to be a closed circle. Greater than or equal to is to the right. Those are all my numbers greater than or equal to negative 4. So again, to solve that, I used my inverse operations. I did the opposite to get rid of minus 6. Let's keep going. Same thing in the next one. Because it says t minus 2, I'm going to add 2 to both sides. So I'll add 2 here. I'll add 2 here. I'll get t is greater than, this time, negative 7. T's by itself, so I've solved my inequality. To graph that, I'll put negative 7 in the middle of my number line and then count up from negative 7 and down from negative 7. And then let's put our dot at negative 7. Because it's greater than, it's an open circle. Greater than is to the right, so I'll draw my arrow to the right. Same thing for the next one. This time, the negative 4 is in front of the y. Notice that I still have to get rid of the 4, and the 4 is still negative. So I still have to add 4. Even though this is a plus, I have to add 4 because the actual 4 is negative. So I'll go ahead and add 4 there, and then I'll add 4 to the other side. Cancels on the left side. The y is positive, so I'm just left with y is less than 3 plus 4 is 7. So I've solved my inequality. To graph that, just like I've been doing, I'll put 7 in the middle, count up from 7, and down from 7. I'll put an open circle because it's less than, and an arrow to the left because it's less than. Less than numbers are to the left. Let's go ahead and take a look at the next one. The next one's a little bit different because the variable is not first, but that's fine. Let's solve it and then we'll deal with that. So to solve it, I need to get rid of the minus 2. I'll do that by adding 2 to both sides. So I'll add 2 on both sides, and I'll get 7 greater than or equal to x. Now, I don't like this because I mentioned in 2.1 we always want our variable to come first. So in order to make my variable come first, I can move it to the other side by switching everything. Basically switch everything over, flip it all, so that x is on the right side, on the correct side. That's my answer. X is less than or equal to 7. Just like before, I'll put 7 in the middle of my number line and count up and down to fill in the rest of the number line. I'll put a closed circle at 7 this time because it's less than or equal to. Less than would go to the left, so I'll draw my arrow to the left. So we just solved all of those by adding something to both sides. In a similar way, we can solve equations by subtracting things on both sides. So that's what we're going to do in example 2. We're going to solve these inequalities using subtraction. So the difference here in example 2, this says y plus 8. To undo or get rid of plus 8, I'll subtract 8 here because then it cancels, which means I have to subtract 8 on the other side of the inequality. So I get y is less than or equal to, careful with your subtraction, 5 minus 8 should be negative 3. So my answer is y is less than or equal to negative 3. I'll put negative 3 in the middle of my number line, and just like I've been doing, I'll count up from there, and I'll count down from there to fill in the rest of my number line. I got to put a closed circle at negative 3 with an arrow to the left because we're talking about less than. Remember, your arrow is going to point the direction of your inequality as long as, and this is important, your variable comes first. So as long as our variable comes first, the inequality is the direction of my arrow. So this points to the left, so my arrow is going left. Let's try the next one. First thing I notice is that my variable is not first, but that's fine. I'll solve this anyways. I'll solve this by subtracting 1.4 because it's being added to m. I have to subtract it, which means I'll subtract it on the other side. Negative 8 minus 1.4 is negative 9.4, less than m. Again, I want my variable to be first, so I have to flip all of this so that my variable comes first. So it'll be m is greater than negative 9.4. When I flip that to get my variable in the front, I have to flip everything. I move the m, I move the negative 9.4, I switch the sign. So now I have m is greater than negative 9.4. Rather than putting negative 9.4 on my number line, I'm going to put negative 10 and negative 9 because negative 9.4 is between those two. And then I'll continue the number line by counting up. Oops, I missed 7. I'll count up and I'll count down. And then when I have to place negative 9.4 on that number line, I'll go right between, it's almost halfway between 9 and 10, and I'll put an open circle. I'm talking about greater than, so my arrow should be to the right. Let's go ahead and try the next one. I need to get y by itself. If I'm going to get this y by itself, I'll subtract the 5 on both sides. So I'll go ahead and subtract the 5 here, subtract the 5 there. I'll get y is greater than 1. That's my inequality. I'll put 1 in the middle of my number line and count up from 1 and down. Open circle at 1 with an arrow to the right. One last one here. Again, this one, my variable's not in the front. I'll solve it and then I'll flip it so my variable will be in the front. I'll solve this by subtracting 2 on both sides. So I'll get 8 is greater than or equal to x, but I want to switch this so that x is first, so it should say x is less than or equal to 8. It's the same thing, 8 greater than or equal to x, x less than or equal to 8. They mean the same things, so we can just switch it. So I'll put 8 on my number line, I'll count up from 8 and down. When I put my dot, I have to be conscious, is it going to be open or closed? Because it's less than or equal to, it should be a closed circle. And then because we're talking about less than or equal to, my arrow should be going to the left. We have one more example. In the next example, we're actually going to write an inequality given some information. So let's take a look at that. Example 3 says, a circuit overloads at 1800 watts of electricity. You plug a microwave oven that uses 1100 watts of electricity into the circuit. Write and solve an inequality that represents how many watts you can add to the circuit without overloading. So how many watts I can add to what I already have. So I already plugged in 1,110. I want to know how much can I add to that. Let's call it W for how many watts I can add. Okay. I don't want to overload the circuit. The circuit overloads at 1,800 watts. So if we hit 1,800 or go above it, it'll overload. We don't want that. So we want anything that is not equal to 1,800, but it can be less than that. So in other words, we want anything less than 1,800. Careful that it's not less than or equal to. We don't want it to equal 1,800 because then the circuit will overload, and we certainly don't want it to be more than that. So my circuit can handle anything less than 1,800. So there's my inequality. I'll solve that by subtracting 1,100 from both sides. And I'll get W is less than 700, which means I can plug in anything that's less than 700 watts of electricity, or that uses less than 700 watts of electricity. So in the second part here, it says, in addition to the microwave oven, which we already calculated, which of the following appliances can you plug into the circuit at the same time without overloading it? So I'm looking for any of these appliances that use less than 700 watts of electricity. Less than 700, let's see, the clock radio uses 50 watts, so we can plug that in. The blender uses 300 watts, so we can plug that in. However, the hot plate is too much and the toaster is too much. So my answer here is I could plug in the clock radio or the blender. In fact, I think I could plug both of them in because total they're only 350. So I could plug in one or the other or both because they'll still keep me under that 700 mark. So solving inequalities looks a lot like solving equations. We solve it and we graph it. So this is really a combination of what we did in chapter 1, which was solving equations, and what we did in 2.1, which was graphing inequalities. So as always, if you need to go back and rewatch this, rewatch any parts of it. Otherwise, that is it for 2.2, solving inequalities using addition or subtraction.